This is a statement of the problem as written. 2 sentences. Interesting question, where the data ends and where the question starts. Working together, in what time they fill the ball, it's still not a question, because it contains additional piece of data working together. So we have properly separate them. The correct parsing of the data is that Bob and Alice, the time in which they work in separate field, and then pretty important assumption. Now they work together. How this can be expressed mathematically, and then converted in the code. In what time they will fill the ball? What does it mean mathematically that they work together? I would suggest, and actually it is a well-known approach in teaching arithmetic. Unfortunately, it was lost in most countries where it was practiced about 50 years ago. And it has to be returned, I believe, back into teaching arithmetic. We have to offer children, students, generic guiding questions, on the basis of which they have to produce their own questions for the problem. Very generic questions. And what can be asked about this data? What can be learned from this data? And the more specific question, how to express mathematically working together. There is no numbers in that piece of data. It is description of a different mode of that. The crucial point is to whom these questions were addressed. 50 years ago, remarkably, and I check it through literature, and the guiding questions were addressed by a teacher or a textbook to students age 11, 12. They were only guiding for guidance. Students were expected to develop their own questions, which solve the specific problem. One interesting observation, the word algorithm was not mentioned 50 years ago. But put together, students' question formed an algorithm. In the sense that after we have the list of questions, then any problem of the same type with different data, when Bob collects cherries, the whole bowl in 10 minutes, and Alice in 5 minutes, or whichever, could be solved following exactly the same step, answering exactly the same questions. It was a way of presentation of an algorithm in human language, but it was a mathematical algorithm. And this algorithm was developed by the student. When we talk about computational thinking, I believe the very first thing which has to be done is to return algorithmic thinking back to school mathematics. It existed before, but was neglected. Two pieces of data, B minutes and A minutes, they will together they fill the ball in T minutes. Pseudocode is just one line. Input A and B. Do calculation with respect to this formula. Return T. If formula T is a fraction, AB divided by A plus B, is quite non-trivial. It is non-trivial to get it. Conclusion. It is important to emphasize that questions and solutions are supposed to be formulated by the student. If these questions are given by a teacher, then the student becomes just a human computer following an algorithm which was set for him or her. The student has to be in control. And it is important to see the steps involved. Much more careful analysis of data, which is normally done at school. Secondly, these questions which naturally become an algorithm, if answered in a specific order. And concepts from computer science. Also, in the solution, it is pretty important that variables are typed. In arithmetic, they were called named numbers. Numbers of people, numbers of apple, numbers of cherries, numbers of kids, and so on, as well as speed in meters per second or kilometers per hour. And two types of evaluation of expressions, by name and by value.